Hello friends, today we are going to solve another interview problem that is maximum contiguous ones after one deletion. Okay, so first let's read the problem statement. So given a binary array, that means the array contains only either zeros or ones. Okay, we need to find the length of longest contiguous ones after deletion of one element from the array. So let's take few examples. If you look at this array, we have 1 1 0 1 0. Okay, and we need to do one deletion. Okay, so if we delete this element, right, this 0, so we'll get three ones together, right? So that will be the longest we can get. We can also delete this one, but in that case the longest would be 2. Okay, so if we delete this, we'll get 3, so our answer is 3. Another example, so 1 0 0 1 0. So here you can delete any element, like you can delete this one, or this one. The maximum length, maximum contiguous sequence of 1 will always be 1. So you can delete 1, then it will be 1 0 1 0, right? Similarly, you can delete this and it's gonna be 1 0 1 0. Yeah, same with the last. So 1 0 0 1. Let's see how we can solve this problem. So let's take example of this array, 1 1 0 0 1 0 1 1 1. Okay, so here we can see that there's no point deleting ones, so we'll always target the 0. So we can delete this, this, and this. So if we delete this, the length would be this, so 3. But if we delete this, then these 4 ones will be together, so our output would be 4. So we know this is the answer. So first we'll maintain a separate array. We'll create a new array or list. Okay, and we'll iterate from left to right. Okay, we'll count the number of ones. Okay, and every time we encounter 0, we'll enter the count of ones into the list. Okay, so again, we are going to iterate from left to right. We are going to count the contiguous ones, and when we encounter a 0, we are going to put the number of ones we have seen earlier in the list. Okay, so let's start from here. So let's say we have a variable called counter, and this counter is going to count the number of ones. So at here, the count would be 1, counter is 1. Then at here, we'll add one more, and once we are here, we have encountered 0. So we'll put the counter value, which is 2, to the list. Okay, and reset the counter to 0. Then move forward, we find another 0. Okay, so the counter is 0 0, put 0. Okay, so every time we encounter a 0, we'll put the counter value into the list and reset the counter to 0. Then we'll find 1, so the counter is 1, and we encounter another 0. So then right now the counter is 1, so we are going to enter 1. Okay, and then reset it to 0, and then we are here, so counter is 1, then here plus 1, then here plus 1. So now we have the iteration is completed. So current value of the counter is 3, so we are going to put 3 in the list. Okay, so now we have prepared a list. So one thing we can conclude from that list is between every 2 element there's a 0. For example, this 2 and this 0, so this 2, right, and this 0, there's a 0 exist. For example, this 1 and 3, so this 1 and this 3, there's a 0 exist. Why? Because we made an entry in the list when we encountered a 0. Now what we can do is now we can find uh, 2 contiguous indexes in this list for which the sum is maximum, right? Because we know that there's a zero exist in between, okay, and we are going to delete that zero. We are going to delete that zero, okay. So we'll iterate this list to 2 0 1 3, okay. So for these two the sum is 2, so for these two sum is 1, and for these two the sum is 4, okay. So our output is 4, okay. So let's go back to the problem, and let's quickly read the approach. So identify all occurrences of contiguous ones in the binary array. For example, given this array, so this is the same example, the occurrence of contiguous ones will be 2 0 1 3, okay. Note that there is no ones between these two, okay. Store these occurrences in a list, iterate through the list and find two consecutive numbers that sum to the maximum value. In our example, the maximum sum would be 1 plus 3 is equal to 4. Handle the edge cases. If all elements in the array are 1, return length of array minus 1 because we need to delete 1. And if all elements are 0, return 0 because there will be no contiguous ones after deletion. So we can solve this problem using sliding window technique, which we have used in another problem. Um, I'll leave the link in the description. Now let's jump to the code. So yeah, this is the same example. So let's see. So we have created a list, and in this list we are going to store the contiguous ones which we'll see during the iteration. So currently the counter is 0, and we'll iterate the array from left to right, and every time we encounter a 0, we'll add the counter value to the list, reset the counter, okay, and else increment the counter, okay. So remember, every time we encounter a 0, we'll store the current counter value to the list and reset the counter to 0. So the same thing. And so this is when we are done with the iteration, and if the counter value is greater than 0, we are going to add it to the list. These are the edge cases. So at this point, we have created our list. So now we need to find two contiguous elements for which the sum is maximum. So this is the first value in the array. The max is 0, and now we are iterating from 1 to the size. Sum first plus um, the next value, and keep track of maximum, update if needed, and then change the first to the next element, okay. So this will give you the sum of maximum sum of two contiguous elements in the list, and then we'll return the max, okay. Yeah, so this is how we can solve this problem, and visit our website tutorialhorizon.com for more interesting problems, and we'll see you guys in the next video. Bye bye.